hope I'm unmuted. I hope people can hear me. I think you probably can. Camera's a little high there. That thing lower. When I set it up, I wasn't slumping, but then started. I got super comfortable. How are you guys doing? It's Tuesday, and this is the OscopeWizard, and I just remembered over the weekend that I rarely introduce myself. I'm Gabe. I'm the OscopeWizard. Welcome to the show. Thank you very much for spending about 20 minutes with me talking about nerdy stuff, most likely. I have the chat open, so if you want to say anything, let me know if anything's wrong. Just drop me a line in the chat. I am actually monitoring it. I'm getting better at it. And I have a new mic system, which is wireless. Hopefully I don't pull the mic out of the camera this week. I did that before. I've done that before. It's a rookie mistake. I'm a rookie. I think this is my 11th show, so I haven't done it very often. First things first. Today, to get ready for the show, I was listening to this album by Alt-J. I don't know if you're familiar with the group, but this is called Relaxer. This is their latest album. It's a little weird. You know how you have a group that you really like, and then they release a kind of a weird album, and you have to take a trip with them. And that trip can be a little hard. They're doing some new stuff. They're doing some things that you've never heard before. But this album has a song called In Cold Blood, which is weird and awesome, and I liked it. Your friends. Oh, to my friends, I am Gabe. To everyone else, though, please address me as Mr. Martin or Your Royal Highness. I will accept Your Royal Highness. That is also in the running. So, anyway, again, albums are cool because they have album art. Cover art is a lost form of art, and we got to bring it back, guys. Get albums. Buy some vinyl. It's cool. Let me put this back up here on its spot. Okay. Let's talk about the weekend. What did you guys do on the weekend? Hopefully you did something fun. A lot of us are caught in our houses. A lot of us are literally locked down, so you can't do a whole lot. Here where I live, we have we had the option to go out. Actually, I did not take that option. I decided to stay at home and keep my distance from other people. But we still had a lot of fun. We have been exploring the culinary arts. When I say we, of course, I'm using the royal we. I am not a cook myself, but over the weekend, we got to try cronuts, which is a combination of a donut, which is awesome in and of itself, and a croissant. Which, I mean, if you have had freshly baked croissants, please, is there a better thing in this world than a freshly baked croissant? Butter that has a little bit of salt in it. When a little bit of salt in it, it brings everything else out. The people in France are so lucky to have this butter. I don't know why everybody in the world is not making their butter like the French make butter. I feel like when someone perfects an item, it should be shared globally. Anyway, I digress, as I usually do. The cronut. This was the dough. It started like that. Uh-oh. Let's see. I got the wrong button here. It goes to this, which is frying dough. It is very difficult to fry dough and make it bad, and the end result was awesome. It was argued at the house whether this was truly a cronut or not. My view was, if you fry dough and you cover it in sugar, it's awesome, so it doesn't matter what you want to call it. I feel like we should probably explore it further and try to perfect it. We have time. Hopefully, did you guys do anything crazy at your house, like make a cronut? I don't know. Let me know. Shoot it into the chat. Let's talk about it. It might be just as crazy as what I did. Another thing that I did was, I didn't actually do this. I just saw this, a fairy garden. appeared in the backyard. We have a lot of time on our hands, and so now we are getting creative with our wildflowers. This was the small arrangement that my tiny junior Oscope, one of my tiny junior Oscope wizards, presented to us in the backyard, and then requested that I did not mow it. You can see the mower in the background there, but you will be happy to know I have not mown down the fairy garden. It is still available. Actually, I think it might have been destroyed, but by the creator, so it was okay. Another thing that happened, I got a new cable modem. A couple of episodes ago, you'll know that I got a cable modem. I plugged it all in. It didn't work. I got a cable modem and it worked, and we have faster internet, which is great because the company that I work for, Ronan Schwartz, has requested that we get faster internet to make our video calls work. So I have complied. Also, it makes this a lot easier, live streaming a lot easier, and most importantly, Netflix 4K looks like $1,000,000. So when we are working from home / binging Netflix, that picture looks great. What else did we do this weekend? I had an old server. I am a nerd. This happened. This is what my old server looked like. It was a AMD E350 processor from 2006, maybe? So a little older. That would be considered a little older. In processor years, that's 1,000,000. Yeah, this is a 1,000,000-year-old. This is a dinosaur. This is dug up from the earth and placed inside of a computer case. The board was so old that the fan on the processor didn't even work. It didn't bother me, though. It didn't bother me. It came out of a tiny computer that I made for home theater service that then has been morphed into 1,000,000 different things. This was my server. Why do I have a server? That is a good question. I use it to store all the videos I make. I use it to store all the home movies I make. It has all of our music on it. It has a Minecraft server running on it. So it gives me a little bit more control. But this old gal is a little beat up and suffering from her age. That happens. So you can get a better picture. You can see it was pretty. I mean, I think this would be considered janky. Janky would be a nice term for what this server was. So I got a new server from eBay, new to me. So I think it was probably a 10-year-old server from eBay. It arrived like this, so that was a little bit of a bummer. You can see that the corner of the box was torn and destroyed. It always makes me sad when a box arrives like that because you know inside of that box is probably not good news. So I opened up the box. Luckily, it was not entirely destroyed. It was somewhat broken, but this is the new server. We were so excited. Well, I say we. That is not the royal we. It was actually just me who was excited. And I was excited because it is fast and I could do cool things. And I'm still working on what cool things I can do. This happens a lot when you're a nerd. You'll get something that you think is going to be cool. And then you realize, oh yeah, I just made this, but now the actual work in making it cool begins. So I've put in some work to make it awesome. Yeah. So there was a question, did I fix the server? The server itself actually operated once I unbent the power supplies in the back. So it did arrive non-operational. But I'm the OscopeWizard, and I do have needle nose pliers, and I was able to unbend the metal and get the thing powered up and turn it on. So I was pretty stoked. Good weekend. Does it run DOS, the server? No, it does not run DOS. Although I know Mr. Rodriguez in past episodes has made some real big pleas to bring DOS back. It does not run DOS. It runs a weird server operating system called Unraid, which is based on Unix. That is super weird and getting very nerdy, which I suppose is totally appropriate for the show today. So I guess nobody else is going to share what they did this weekend. That's okay. Maybe you did something weird, like sat on your back deck in your inflatable hot tub, which I also did. Or maybe you had a glass of Merlot, which is a pretty corny dad joke. I had a lot of Merlot. So let's get to the weird probe drawer. Uh-oh, somebody played Animal Crossing this weekend, which is awesome. And they started a Raspberry Pi project, which I love the idea of a Raspberry Pi project. I mean, clearly I'm doing it basically every episode. Other people stayed home, sat in their garage, and ate, which, I mean, yeah, that was me too. I hung out, ate a lot, had hamburgers and hot dogs one day, which was a big treat. We've been doing a make-your-own pizza at the house, which is pretty exciting. When we talk to our friends, it sounds like we're going out to eat all the time, but we are just cooking the things that we normally go out to eat to get. So that's been kind of exciting. We're getting very good food at the house because my wife, Mrs. OscopeWizard, is awesome at cooking. So very lucky here. What's in the probe drawer? I have a giant drawer. You saw it a second ago. Of course, it blew by. So in the techno layer, I had this huge drawer full of probes and other various assorted randomness. And I yanked out of that drawer today this guy. Dun, dun, dun. It is the, let's turn this off, RT-ZS30, which is a very exciting probe. Let's talk about why do you even care about probes to begin with, and what in the world is a probe? And also, let me begin my timer, so I don't take up all of your time. What is a probe and why do I care? These are very, very good questions. So let's grab some probes. Hold on. Besides the ZS30, which is the probe that we're gonna look at today, let's talk a little bit about cables and connectors and probes and all the fun things that have to do with electronics, looking at those signals. So a big part, my job as an electrical engineer in the test industry is that I want to test signals. I want to test electrical signals. I want to see what they look like, they're the right shape, doing the right things, going the right speed. And there is a stark divide in my industry. There are two camps that my industry is divided into, pretty much. Actually, I'll say three camps. Three camps that my industry is divided into. There are the RF people, the people that work in the radio frequency world. Let's see, I think I can even type here. So let's see. There are the RF folks. There are the digital folks. And then the power folks. See, I think I can. There we go. RF folks, digital folks, power folks. And that's kind of how my industry breaks down. And all of us need to be able to get signals into our test equipment. So over here, I have some test equipment. Today, we have, whoop, let's turn on the light so we can see it. I have the RTP 16 gigahertz oscilloscope. It is super duper fancy. And I have to get signals from my Raspberry Pi in the case of today, because big surprise, I'm doing a Raspberry Pi. I have to get signals from here into here. Now, RF guys, RF folks, a lot of times they will have a connector. So they'll have something like this. sitting on the side of their test equipment. And that connector, I would consider cheating. They would consider it necessary. Guess we'll have to agree to disagree. By the way, I kind of sit in the digital realm of things, folks. That's where I like to play. That's what I specialized in college. And that's what I really love about electronics is digital communications, digital processing. So the RF guys will have a connector like this. Now, why does an RF guy usually have a connector? Because the RF guy usually has an antenna. I think it's an antenna because antenna starts with an A. It means you use an instead of a. Hot English lesson there. Hot English. So since they have an antenna, they usually, did I just say a antenna? I think I said an antenna. I don't know. If my English teacher were watching, Miss Stevens, she would be appalled and force me to diagram it 17 different ways. And she would be correct. I probably should. So an antenna has a connector. Now, that means that I can just use a cable to connect to this connector. Getting real meta in here. I can just connect to the connector. And then I can plug the other end of that cable into my test equipment. And do it very simply. Oh, maybe not as simply if you're on camera. Ah! There we go. Super simple. Super simple. Just like I said. That is how the RF guy usually connects. But then when it comes to power guys and digital guys, we usually don't have awesome connectors where we need to probe. So we have to use probes, which is, I mean, that's the way the world works. You have to use, oftentimes, when you get a new oscilloscope in the mail, which if you haven't gotten one lately, grab one. I can only encourage you to get a Rotor and Schwartz oscilloscope because they are spectacularly awesome and designed by German elves in the mountains of Bavaria. I don't think that is true, although there are mountains very near where they are designed. So, yes, yo dog. I do need a connection to make my connector to my cable connector connection. Yes, that's a lot of the same word. It's like a tongue. What I'm showing now on the screen is a very typical probe. This is the classic passive probe. Got a hook on the end. Generally, you can see the hook right there. And then for the ground side of the probe, this is a single-ended probe, meaning that it can probe but a single signal. It's right there in the title. A single-ended probe, so it can probe one signal using this hook, and then it connects to ground. Now, I need to connect to ground to make sure that my test equipment is on the same reference as my device. It's called a device under test, a little inside info. So this is the passive probe that comes with every new oscilloscope, pretty much. And if your scope didn't come with passive probes, you might need to buy a different oscilloscope because any kind of decent oscilloscope should come with some passive probes. You have to have a way of getting the signal from your device into your test equipment. Now, this probe is cool because it is essentially included for free with the purchase of an oscilloscope. But the downside of this probe is it only has about 500 megahertz. And as configured right here, it only has about 50 megahertz of bandwidth. So in a previous episode, we talked about bandwidth and how that affects the signals that you can look at. But for instance, this little USB stick right here has signals on going out of it because it's USB 3 device. It has signals coming out of it that go at 5 gigabits per second. That means I need way more than 50 megahertz of bandwidth to probe it. I need more like 10 gigahertz to probe this little guy. That's what you're going to need to properly probe it. So, dun, dun, dun. One might need to get a slightly faster probe. And that is where something like the RT-ZS30 would come in. Oh, yeah! Let's take a look at, drag the chat out of the way. Let's take a look at the datasheet. Datasheet is always a great place to start when you're learning about a new piece of equipment or a new device that you purchased, or if you are designing something. You should probably at least glance at the data sheets, because the data sheets are going to have a lot of pretty pertinent information, and the same can be said for a data sheet of a probe. So here is the data sheet, or actually the user manual, which includes all the data for the ZS30. It also has the ZS10 and the ZS20 and the 10E. It's all kind of bundled in there together. See if I can fit this on the screen. Drag. Yeah, I can. There we go. That looks pretty good. Can everybody see it? I think so. Now, I want to find out some basic stats on my ZS30. So let's see if we can find some key features right here. The ZS30, the bandwidth goes from DC, which is 0 hertz. That is no hertz at all. Usually that's a power supply or a logic line that doesn't change much. DC up to, or direct current, up to 3 gigahertz of bandwidth. So that is a lot of bandwidth. For instance, Wi-Fi, which is in probably everybody's house, runs around at 2.4 gigahertz in general. Most Wi-Fi sits at 2.4 gigahertz. Bluetooth headphones that everybody's running around with these days, that sits at 2.4 gigahertz. So you could use a probe like the ZS30 to look at a signal at 2.4 gigahertz because it provides 3 gigahertz of bandwidth. Another cool thing about this probe is that it has a dynamic range of plus or minus 8 volts. That kind of lets you know how big the signal can be that you're going to use, or sorry, that you're going to look at with the probe. So if you were to look at, say, a 20-volt signal, or if you needed to look at a 20-volt signal, this wouldn't be the right probe for you. You would need to go search for a probe, or maybe a different accessory to make this probe useful. Also, the non-destructive input voltage, plus or minus 30 volts. If you go outside of 30 volts with this probe, good chance you're going to break it. So this is a very important number. It's going to be in every probe data sheet. It will show you bandwidth. It will show you the dynamic range, which is how big of a signal, and then what is the point of no return when you have turned your probe toast, which is not great and doesn't smell. Input resistance, 1 mega ohm, which is 1 billion ohms. Billion ohms. This is important because I need my probe to have a lot more resistance or impedance than the system that I'm probing. Why is that important? Because current, like water, takes the path of leak. So if I plug in low resistance probe into my circuit, then current will begin flowing into my probe. I don't want that because that's going to be stealing current from my circuit, and it's going to cause all sorts of problems down there. So a high input resistance is better. Input capacitance works a little bit the same way. You want this number to be as small as possible. This passive probe that I was looking at before has about generally 12 picofarads of capacitance. This RT-ZS30 has 0.8 picofarads of capacitance. So an order of magnitude less capacitance, which is good. Now let's look at page in here that talks about how you can connect probe with different accessories, and then the response. Every data sheet will have a picture of the probe response. So this is the ideal step response. This will tell you how fast of a rise time can I look at with my probe, which is kind of important because that has to do with the bandwidth that the probe is capable of. So a faster signal would require more bandwidth, edge straighter. This is all super nerdy probe stuff, but you know, when you're looking at probes, let's get deep, guys. Let's get super deep. Here is the page that I wanted to show. Rotate clockwise. Now, the probe comes with all sorts of little doodads inside of it. Regular signal pin with the ground pin, which we'll look at. We're going to actually try to use this probe. Then we have some longer ground leads with the signal pin. And then we have ground leads, so this long ground lead with kind of a long signal lead. And you can see how the bandwidth is affected. So if you use the shortest accessories possible, the probe is rated at 3 gigahertz, which is great because it's a 3 gigahertz probe. So you want to try to get the most bandwidth as possible. Now, if I start making that ground lead longer, why would you make a ground lead longer? Because it's way more convenient to have a long ground lead to plug into ground. It's really inconvenient to have this tiny little ground lead. So a lot of engineers will use the tiny pin for the signal and then the long ground lead. What have I done? I have halved my bandwidth. Now this 3 gigahertz probe is a 1.3 gigahertz probe. Bummer, I think that is called a fail. But needs must, guys. Sometimes you got to use the accessory that works. That is all about engineering. So there's always compromises when it comes to engineering. Everything can't be perfect all the time. Work. Now, if you use a ground lead and a signal lead, my bandwidth is all the way down to 700 megahertz. So I have dropped my bandwidth precipitously from 3 gigahertz all the way down to 7 megahertz. Of course, this is the easiest way to plug it in. The easiest way isn't always the best way, but it's generally the easiest. And it's also generally the way when I walk into a lab that I see the probe plugged in. And it makes me wonder, if you're going to spend all this money to get a ZS30, so a 3 gigahertz probe, they are not inexpensive. They are thousands of dollars. Why would you plug it in like this? I mean, just get the cheaper probe if you're going to plug it in like this. It's silly, guys. Silly. So let's rotate this. Actually, let's rotate back to my setup here. Now today, before I get too deep into the ZS30, probably going to do a couple of days on the ZS30, and then we'll see what else is in the drawer, because you can see there's a ton of boxes in the set that aside. I have another cool accessory. This is called the RT-ZAP, or the ZAP. Clever name. That is pretty unusual for any sort of probe accessory. The reason I wanted to show this guy, I think this is one of the most useful probe accessories that there is. It is a probe positioner, so a 3D probe positioner. As you can imagine, holding the probe steady with your hands, tough. It's a tough business. I mean, can you take a video steady with just your hands? Are you good at that? Especially before the camera started to build in image stabilization. Before image stabilization, everybody's camera looked like the Blair Witch Project all the time, 100% of the time. And then after image stabilization, everybody's videos suddenly looked so good. This is basically the stabilizer of probes. So it stabilize how this probe goes. So let's put it all together. A couple of pieces here. I have this base, which is a good heavy base, so I'm probably going to drop it. Let's get the box out of the way. Plug our arm base. Light on it. So, probe positioner. going to make your life in the lab a lot easier. It's like another set of hands. No longer do you have to ask Charlie to come over and hold your probe while I hit the buttons on the front of the scope. I need help, Charlie! Where are you? Here is the ZS20, or the ZS30, sorry, the ZS30. I'm going to put it in the probe positioner here. Knobs and dials. I have a bunch of knobs and dials. Can't ever remember which knob does what adjustment. Let's figure out which knob does what adjustment. Okay, there. That knob is making the mouth smaller. Let's make the mouth down on my probe. Cool. I have the probe in a very comforting embrace. Jaws of this probe positioner. Now, I can put this probe however I want it. Use this little knob right here. Righty tighty. Boom! It's like magic, guys. That is literally like magic. It's crazy. I mean, oh, I see Charlie. Charlie's on the line. He is gonna help. Thank you, Charlie. I'm calling you out. You're not helping. You're not responding. He is there. He is there. Thank you, Charlie. This is Charlie. You don't have to come to the house. So get out of the car. It's okay. I have the probe positioner. You have been replaced by a probe positioner. But man, I really appreciate the offer. Oh, so this is cool. You could make probe art. Kind of cool. You have it however you want. It'll be, shining probe, maybe the sitting probe, contemplative probe, thinker. So the probe holder, super awesome. If you don't have a probe holder with your probe, you should consider getting one. The RT-ZAP is a great option. There are other probe holders. There are less intricate probe holders out on the market that simply just have 2 feet and they kind of hold it like that. This is my favorite one. You can use it to hold probes. I have had customers use it to hold their semi-rigid cables. Those can be a little bit heavy and they can drag down. Uh-oh, what does that mean?
5 minutes left! I was
Guys, 5 minutes left. So we need to wrap this episode up for today. Let's go back over what we talked about, reintroduce myself, wrap it up into a nice little package, put a bow on it, put it out. Recap. I'm Gabe, the OscopeWizard. Thank you so much for joining today. We talked about probes, the probes that were in my drawer. I talked about RT-ZS30. We get it in focus? There we go. The RT-ZS30, single-ended 3 gigahertz probe. Single-ended means it can look at one signal at a time. We also talked about why you would use that 3 gigahertz probe over standard 500 megahertz passive probe. Because you want more bandwidth. You might be looking at a signal like a USB signal that requires more than 500 megahertz of bandwidth. Did I just say 500 gigahertz? 500 megahertz. That little passive probe is 500 megahertz. Big fancy RT-ZS30, 3 gigahertz. You might need it to look at something that goes faster, USB signal, maybe express signal, which is standard signal type used all your cool graphics cards. If you are using a graphics card in your computer now, right after this show, you are going to go play PUBG. It's probably a PCI Express graphics card. And then you would want a probe with the appropriate amount of bandwidth. We also talked about probe positioners. Probe positioners are cool because they're like an extra set of hands in the lab, and they can hold a cool 3D probe positioner like the RT-ZAP or RT-ZAP. Can hold the probe in all kinds of different configurations, so it frees up your hands. Now you can press the buttons. Pressing buttons is way more fun than holding probes. And then on the next episode, we may actually probe a signal. Very exciting. I am so excited. I really appreciate you guys joining today. Oh, my mic fell off. I got so excited I pulled my mic off. Who knows how long it's been dangling. Let's check the chat. Let's make sure I didn't miss anything. I do agree Charlie should make some abstract probe art in his spare time. I don't know why that already hasn't happened. Seriously, Charlie, get on it. What else? Feel like we're good in the chat. I am going to be hanging around for a little bit after I hit the end button. And if you have any questions, please throw them into the chat. Next episode is at 11 a.m. Eastern Standard Time, United States. If there's another Eastern Standard Time, there might be in Russia, but this is the United States Eastern Standard Time, 11 a.m. Please check it out, OscopeWizard.com. Tell a friend. Tell a friend. My mom can only tell so many people because she's stuck at home. But if you're not stuck at home, you could shout it to them through your mask. OscopeWizard.com. Come on Thursday and let me know what kind of weird music you're listening to. I mean, I got into Spotify over the weekend and listened to 90s rock anthems and really had forgotten entirely about Candlebox. It's worth a review if you've forgotten about Candlebox as well. Look it up. Spotify 90s rock anthems. See you next time, guys. Thank you so much for joining. I appreciate it. Bye.
5 minutes left.